All right. Today I'm going to introduce the concept of logarithm. And in its simplest term, you can think about logarithm as an exponent. Okay. Now we're going to start with the log form or the logarithmic form. Down below we have this equation: the logarithm to base b of x is equal to y. So this is the logarithmic form. The logarithmic form or the logarithmic equation we read like the logarithm to base b of x is equal to y. Now this somehow that doesn't make sense, okay, to me. So what I do is rewrite this in its equivalent form, which is very familiar to us. We call it the exponential. Okay, so how do we rewrite this in its exponential form? So you start with the base b and then raise to y is equal to x. Okay, so start with the base and then raise to that y is equal to x. So this is the exponential format that's equivalent to that logarithmic form. Okay, so let's look at the first example here. Let's say we have the logarithm of, say, 10,000 to base 10 is equal to x. Okay, so when we say solve this logarithmic equation, we're going to find the unknown x. Now, there's something that we need to remember, okay, that whenever we have a logarithm of something, say x to base 10, you can also write that as simply the logarithm of x. Okay, so the logarithm of x, when the base is missing, it's understood to be 10. And also when we have a logarithm of x to base e, now e is some kind of irrational number. Irrational means it's a never-ending decimal, non-repeating and non-terminating. This is something we cannot be able to convert to fraction form. Okay, so this is similar to the pi. That's 3.1415 and so on. Okay, so both of them are irrational number. Now the logarithm of x to base e is equivalent to ln of x or natural log of x. So the logarithm to base e, the shorthand notation for that is ln or natural log. Okay, so those two, we need to remember those notation right here. Okay, so let me just clear that. All right, so let's go back to our example one. So let's say solve this logarithmic equation. Log of 10,000 to base 10 is x. Okay, so first thing we do is change this to exponential. Okay, so we're going to start with the base 10, and then we're going to raise this 10 to what? To x is equal to 10,000. Well, we know that 10,000 is a power of 10, meaning we can write this 10,000 using exponential like 10 raised to a number 4. Okay, now 10 to the x is equal to 10 to the 4th. Knowing that their bases are the same, it implies that their exponents must be the same also. Okay, thus our solution is x is equal to 4. Okay, so look here, log of 10,000 to base 10 is 4. And again, I said that earlier that logarithm in its simplest term is an exponent. As you can see here, the exponent of 10 must be 4 in order to get that 10,000. Okay, so let's look at example 2. Let's say you're asked to solve log of x to base 4 is equal to 2, or log to base 4 of x is equal to 2. So again, what is this in exponential? In exponential, it's 4 squared is equal to x. Now this one is very straightforward because we have this x on one side isolated, and that's equal to 16. Okay, and number 3, let's say we have to find the logarithm of 1 over 81 to base 9 is equal to x. In exponential form, this is 9 to the x. Okay, so again, that's 9 to the x equals 1 over 81. Now, 81 is a power of 9, but we know that 9 raised to the second power is 81. It's not 1 over 81. So what we do is, first we write that 81 as 9 squared. Now, there's this property of exponent that allow us to bring this number down here to the numerator. Okay, and every time you do that, make sure you switch the sign of that power 2 to a negative. Okay, so you switch the sign. So that's one property of exponent. You can bring this up or move this number from denominator to numerator as long as you switch the sign. Okay, so knowing that their bases are the same, then their exponents have to be the same, which means that the solution is negative 2. Okay, so let's look at the last example. Let's say we have this equation logarithm of x to base 1 over 9 equals negative 2. Again, the exponential form for this is 1 over 9, okay, raised to the negative 2 is equal to x. Okay, we just have to simplify this 1 over 9 raised to the negative 2. So x equals 1 over 9 raised to the negative 2. Okay, you can raise 1 to anything, it's still gonna be 1, right? So 1 to the negative 2, when you distribute this exponent negative 2 to 1 and 9, you have something like 1 to the negative 2 over 9 to the negative 2, which is the same as 1 over 9 to the negative 2. Again, the property of exponent can be applied here. So you bring this up one more time. Okay. So the 9 to the negative 2 is now numerator, but make sure you switch the sign. Okay. Now down below is just going to be 1. So 9 squared is 81 is going to be our solution. Okay, and that's about it for this introduction of logarithm. And thanks so much for watching.